Hello and welcome to the new video lecture. In this video lecture, we are going to discuss about the topic that is covering the flow control. Basically, the flow control is a set of procedure that will tell the sender how much data it can transmit before the data overflow at the receiver side reached. The receiver has a limited speed and limited memory to store the data. The receiving device must be able to inform the sending device to stop the transmission temporarily before the limit is reached. The control flow in the computer networks is divided into two protocol levels. The first one is the stop and wait, and the second one is the sliding window protocols. Here we will learn about the stop and wait protocols and its basic mechanism of working. From the figure it is clear that there is a sender and we have the receiver. The sender is going to transmit some data from left hand side towards the receiver. After getting the data at the receiver generates some acknowledgement signal and until the sender stops transmitting any kind of data until it receives an acknowledgement from the receiver side. So obviously there is a delay involved for the next transmission. After getting the acknowledgement from the receiver, the sender again starts transmitting the data from the sender side towards the receiver side. Again the same procedure repeats and finally we have the end of transmission when there is no data remaining from the sender to approach towards the receiver. Stop and wait protocol and its working. From the name we can say stop and waits. Initially the data is sent from the sender side to the receiver side, and now sender wait for an acknowledgement, and once acknowledgement is received it again sends the data. It continues till the whole is transmitted. At the end of the data, after receiving the acknowledgement, the sender sends EOT, that means end of transmission. Here we have some time functions. The first one is the transmission time, that is represented by capital of T and small t in the subscript. The time it takes for station to transmit a frame. The next one is the propagation delay, that is TP by TT. The time takes for a bit to travel from sender to the receiver. So total time for one complete transmission is, from the figure you can see that we have sender, it takes transmission time of TP, and again TP time is taken for getting the acknowledgement. So the time takes for a bit to travel from sender to the receiver, so that total time for one complete transmission is defined as time TT, transmission time, plus twice of propagation time. Transmission time when the sender is approaching or starting, or the sender is taking a time to transmit the data, that is marked by capital T small t in the subscript, and the capital T small p in the subscript denotes here the propagation time. That will be twice of propagation time plus transmission time will give us the total transmission time for one complete transmission. Now the efficiency for the link utilization can be calculated by this formula. It will be transmission time divided by the transmission time plus twice the propagation time, or we can say the total time. So we can take the TT common here. So in the denominator part we have 1 plus twice of Tp by Tt. If we will represent Tp by Tt as a small a, we can find out the link efficiency by the given formula. That will be 1 divided by 1 plus 2a. Now if you have some numerical problem in which you have offered or you have given the propagation time and the transmission time, so you can easily calculate by utilizing this formula the total link efficiency of your transmission. So thank you very much. In the next video lecture we will learn about the next protocol, that is the sliding window protocol.